we're going to go ahead and continue finding our different normal probabilities. Again, as we're going through, we're thinking that we have a continuous probability distribution here. We are using our standard normal model, and we are using our standard normal probability table to find all of these probabilities. So in example 6, our normal model N29.5, 1.2 gives a good approximation of the distribution of Pacific Harbor seal pup's newborn lengths in inches. Suppose we were to select a seal pup at random, and we are going to record, it should say length and not weight. All right, as we're looking at our notation, remember the capital N stands for the fact that we have a normal curve. The first number, in this case our 29.5, is our mean. So our 29.5 is going to go in the center. And then our 1.2 is our standard deviation, so we're going to use this to move to the left and the right. To move to the right, we're going to add 1.2 each time. Right? So we add 1.2 to 29.5, we get 30.7. We add 1.2 again, we get 31.9. We add 1.2 again, we get 33.1. Right? Moving to the left, we take our 29.5, we subtract 1.2, we get 28.3. We subtract again, we get 27.1. We subtract 1.2 again, we get 25.9. Now we're going to look at our question. Our question says, what is the probability of randomly selecting a seal pup that is shorter than 28 inches? So in our case, we're going to find where approximately 28 inches would be on our curve. And since we are thinking about shorter, we are going to shade the area to the left. As we're looking at these areas, remember that the amount that is shaded in is going to correspond to our probability. So when we are done with this problem, we have a relatively small portion of our curve that's shaded. We should end up most likely with a relatively small probability. So our z-score, right? Our z-score formula, x minus mu over sigma. X is the number that we are looking at. So in our case, we're looking at a length of 28 inches minus our mean, our mu, right, which is 29.5, divided by our 1.2. If you are plugging this into your calculator all at once, make sure you put the top portion in parentheses as we have before, or you can do your subtraction and then do your division in 2 steps. Either way, we should end up with a z-score of negative 1.25. So now we're going to look up this z-score in our table, and we are going to find the area to the left of this z-score. Right, so here I have a printed copy of our standard normal probabilities. Now, same thing that there is a link provided to on the Moodle page. Looking at the front side, we have our negative z-scores. Back side again has our positive z-scores. In this case, we're looking for a z-score of negative 1.25. So we're going to, on our table, move down our left column to where we see negative 1.2, right? And then we are going to move to the right to find our value. Right? It may be beneficial to have another sheet of paper or a ruler handy. So as we look at this, we move over negative 1.2 all the way over to our second decimal up at the top, right? The 0.05, we're just focused on the 5 part. And that gives us a value right here of 0.1056. That's going to be the number that is our area to the left of z. So 0.1056. Right, now looking at our picture, right, we have shaded our area to the left because we are thinking about shorter than. Right, so in this case, this number that we have here is going to match up with this. So we are looking for area to the left. Our area to the left is this 0.1056, and so we're going to use this to find our probability. So we're going to say the probability of randomly selecting a seal pup shorter than 28.0 inches is about 11%. So we take this 0.0156 and we round it off to our nearest percent. Right, so it's about 10.5%, so we're going to go ahead and round it up to 11%. All right, example 7 that we have below, we're starting off with our same model. So I'm going to start by labeling my curve just as I did in the one above. Our mean is still 29.5 inches. Right? So as we label our standard deviations going to the right, we're adding 1.2 between each of our values. Then as we're labeling our standard deviations going to the left, we're subtracting 1.2 from each of our different values. Now in this particular example, we're asked to find the probability of randomly selecting a seal pup that is between 27 and 31 inches long. Right, so in this case, we are looking for a probability that is between. So looking at our diagram, 27 would be right around here, 31 is going to be right around there, and we are looking for the area in between, so we are going to shade the area in between these two different values. Here we have a relatively large area that's shaded in, so we should expect that we end up with a relatively large percentage when we are done with this problem. All right, so now that we have our picture sketched and we know what we're looking for, we're going to find our z-scores. That is our second step. I'm going to go ahead and use 27 for my first value. Right, so again, whatever number is in question, that's always our x, that's the number that comes first. Right, and then we're going to subtract our mean. So minus 29.5 divided by 1.2. Again, if you're plugging it into a calculator all in one step, make sure you put parentheses around your numerator. Right? We divide this, subtract and divide this out, we get negative 2.08. Then we're going to find our other z-score. Our other length that we have is 31. So 31 minus 29.5 divided by 1.2. Again, if you're plugging it into a calculator all in one step, make sure you put parentheses around your numerator. And this is going to give us a positive 1.25. So now we're going to move to our table. And as we're moving to our table, we're looking for two areas. So we're going to find the area to the left of our z. Our first z is negative 2.08, and our second z is 1.25. So we're going to be looking up two areas to the left of our two different z values. All right, so we're going to go to our table. In our table, our first z-score is negative 2.08. So we are going to use our table. We are going to move down on our z-score column to the negative 2.0 row. And then from here, we are going to go over, find our second decimal value. Our second decimal value is an 8. So we're going to move all the way over to this column. So our first area is 0.0188. So 0.0188. Right, our area to the left of our other z. Well, now we're positive, so we're going to flip our table over. Right, we are positive 1.25, so we're going to find our row that starts with 1.2, move over into the column that has the correct second decimal value, so our column under the 0.05, and this gives us an area of 0.8944. So 0.8944. Right. As we are doing these problems, again, here we are looking for our area between. And when we are looking for an area between, we want to take our two values and we want to subtract them. So 0.8944 minus 0.0188 gives us 0.8756. So the probability of randomly selecting a seal pup between 27 and 31 inches long is about 88%. So example 6, we are looking for a length that was shorter. We used our area to the left. In this example, example 7, we were looking for the area between. So again, we found our two different z-scores, found our two different tables values from the table, and then we subtracted them to find our area in between. Remember, if we were to do a case where we were talking about area to the right, we're thinking complement, so we end up subtracting that from a value of 1. As we are going through and working through these problems, this is going to be another case where, as we did with some of the stuff in Chapter 3, Statcrunch is going to make the amount of work that we have to do a lot less steps, a lot less different things to do. I will go through, after I talk about the different steps on Statcrunch, record a quick video that actually shows me finding a couple of these values and the actual buttons to press. So that way, if you do want to take a look at that video using Statcrunch, I will do some screenshots of my computer as I'm working through these problems. All right, so using Statcrunch, the first thing we're going to do is we're going to select Stat in the heading at the top. We're going to scroll down in that little list until we see Calculator. Then we're going to select the one that says Normal. Again, we're working with a normal distribution. We're working with normal probabilities. So we're going to select our normal calculator. In here then, we're going to enter our mean and our standard deviation. Once we enter those values, we're going to pick standard. Standard is if we are doing a less than or greater than, and between is if we are looking for two different values. So when we get in here, we want to make sure that we have the correct one selected. Once we do that, we're actually going to have a place to enter the values that we're looking at. So we're going to enter those in. We're going to select Compute. That's going to give us our answer. And then up at the top, there's a button that says 68, 95, 99.7 ticks. That will actually make our problem so that way it's labeled exactly like our sketches are. So previously on the one of the last examples, we were looking for the probability of randomly selecting a seal pup and recording its length. And we were asked about a seal pup that was shorter than 28.0 inches. So what you see here is actually your output that Statcrunch gives you. Right? If we look at what we have down here, notice that our curve looks very, very similar to our curve that we did on the previous page. Right? So those match, our labeling matches up exactly. Underneath here is the information that we have input into Statcrunch. So what we're going to plug into Statcrunch, we're going to find and plug in our mean. Right? So again, that's always the first number after our n. Our standard deviation, we enter that number as well. We want to make sure we pick the correct symbol. So I selected a less than symbol, and then we make sure we put in the value in question in here. So I entered a 28. If we look at this answer, our answer that we got on the previous example from a table was 0.0156. What we have here is the same. Right? So this answer rounds to about 11%, just like our previous example did. In example 7, we also used the same model. Again, we are looking for the seal pup's lengths. Right, we sketched our curve. We use the same labeling along our horizontal axis as we did before. When we go into this problem, we keep our mean the same, our standard deviation the same, and then in this case we would select the between option up at the top, right, and enter our two values. It's always going to look like a double less than, and our smaller number is always going to be on the left, our larger number is always going to be on the right. And then what we're going to get here, again, also rounds to about 88%, as it did in the example 7 that we just worked by hand. All right, so the next few examples, I'm going to talk through, show the different results that we get when we enter these into Statcrunch, talk a little bit about that, and then again when I'm done, I will also post a video of a few screenshots, different things that we want to keep in mind as we are plugging things into Statcrunch. Okay, so in example 8, we are looking at a normal model, 500, 100. It gives a good approximation of the distribution of the quantitative SAT scores for college-bound female high school seniors in 2012. So the first thing we're going to do is we're going to sketch our curve. So our mean is 500. Our standard deviation is 100, so we're going to move to the left and to the right. Each time going up to the right and then going down to the left by 100. Again, as you're working through these, feel free to have a calculator handy to do some quick labeling. Right? In this case, this particular example, we're asked to find what percentage of female college-bound students had scores below 400. So looking at this, we're going to go draw in our vertical line at 400. Below means we're going to shade to the left. Again, a relatively small area that's shaded, so we should expect a relatively small percentage for our answer. In Statcrunch then, what we are going to enter, again, we do this by going to our normal calculator. So we select stat, we select calculator, we select normal, and then we're going to enter our different values in. So in our mean, we're going to enter 500. For our standard deviation, we're going to enter 100. Right. We have a P, and then we're going to have an X. Right. So what we're going to do, we're going to make sure we choose the less than or equal to symbol, since we are thinking about scores below 400. And we're going to put that number in as 400. And then we're going to select compute, and that's going to give us 0.15865525. So if we round this off to a percent, we're going to say about 16% of female college-bound seniors had scores less than 400. Right. Unlike some of the stuff that we did in Chapter 3, notice that our sentences that we've been doing in this entire section have been pretty straightforward. Talk about what you're looking at in your problem, what probability or percent are you looking for, so make sure you state that, and then make sure you round it off accordingly. All right, so a couple more problems to work through on the next page, again using the same normal model. So our mean was 500. Moving to the left, we're going to add 100 each time. Moving to the right, we're going to subtract 100 each time. And in this case, this particular problem, we are asked what percentage of female-bound students had scores above 650. So in here, we're going to draw a vertical line right around where 650 would be, and we're going to shade to the right. Again, in Statcrunch, remember we're doing stat, calculator, normal, right? Because we're using our normal calculator to do these. And then we're going to input our values. Right? So our mean is 500. Our standard deviation is 100. Now we are looking for the probability that X, again, we're going to fill in a couple of things in here. Right? We're going to select a greater than or equal to, because we're thinking above, right? Above 650, and that gives us a value of 0.066872, which rounds to about 7%. So So we're going to say about 7% of college-bound females had scores above 650. Again, in both A and B, we had a relatively small area that was shaded. We had a relatively small corresponding percentage. Last but not least, so for this last one, we are going to look at our normal model. Again, still a mean of 500, still a standard deviation of 100. So we're going to label our curve appropriately. This time we are asked what percentage of female college-bound students had scores between 450 and 600. So we're going to draw a vertical line in here approximately where 450 would be, a vertical line where 600 would be, and then we are going to shade the area in between. All right, so again, as we are entering this into Statcrunch, right, our mean is 500. Our standard deviation is 100. This time when we're looking at our probability, we're going to select the between option at the button on the top of our normal calculator. And we're going to put our two values in here. Our smaller value comes first. Our larger value comes second. And then after we select compute, 0.53280721. Or about 53%. So we're going to say about 53% of college-bound seniors had scores between 450 and 600. Right. These last three examples I've worked through using Statcrunch. The nice thing about Statcrunch is even if you are asked to, and there's a couple of questions in particular in the mini quiz where you do have to work through these by hand, I am going to be looking for a z-score and specific values at the table. You can always use Statcrunch to double check the ones that you calculate by hand as well. Okay. So that's going to wrap it up for the first part of section 6.1 where we're finding normal probabilities. And then we're going to finish up section 6.2 by looking at our inverse normal value.